Assalamu alaikum. Today my topic of presentation is composites. Let's have an introduction to composites. We can have many types of composites. Going through the slides, we will see constitution and classification of the composites, particle reinforced composites, fiber reinforced, metal matrix fiber composites, hybrid composites, structural composites, and their applications. Processing of fiber reinforced composites, application of composite materials. So, uh, first we need to know what is a composite material. So, two or more chemically distinct materials which when combined have improved properties over the individual materials are called composites. Composites could be natural or synthetic. Next, importance of the composite material. Composites are very strong and stiff, yet very light in weight. So ratios of strength to weight and stiffness to weight are several times greater than steel or aluminium. Fatigue properties are generally better than for common engineering metals. Toughness is often greater too. Composites can be designed that do not corrode like steel because in composites we see they corrode, but these composites are designed in such a way that they do not corrode. Possible to achieve combinations of properties not attainable with metal, ceramics, or polymers. Yes, this is our aim. We have composites because we need properties which we couldn't find in metal, ceramics, or polymers. Next is the properties of the composites. In selecting a composite material, an optimum combination of properties is usually sought rather than one particular property. Fuselage and wings of an aircraft must be lightweight and be strong, stiff, and tough. Several fiber reinforced polymers possess this combination of properties. For example, we can have natural rubber alone is relatively weak, we know. Adding significant amount of carbon black to NR increases means natural rubber increases its strength dramatically. Next, we can see classification. Classification, okay, we have two types of composites. The one which is traditional composite and the other which is synthetic composites. So let's see traditional composites first. Composite materials that occur in nature or have been produced by civilizations for many years. For example, wood, concrete, asphalt. Whereas synthetic components are the man-made or made in laboratory or industry. Modern material systems normally associated with the manufacturing industries, as we can see here, in which the components are first reduced separately and then combined in a controlled way to achieve the desired structure, properties, and part geometry. Next, we have phases. Nearly all composite materials consist of two phases. The one is primary, the other is secondary. Let's see what is primary phase. It forms a matrix within which the secondary phase is embedded. Secondary phase, embedded phase, sometimes referred to as an reinforcing agent because it usually serves to strengthen the composite. The reinforcing phase may be in the form of fibers, particles, or various other geometries. Here I have a diagram to better understand the concept. See, there is matrix which is continuous. The dispersed is discontinuous and surrounded by matrix. Matrix phase is symbolized in this diagram by this arrowhead, and dispersed phase is shown as well. We can have we are having some more diagrams here in which we have discussed different orientations for the dispersed phase and matrix phase. Next important thing is a function of the matrix. It binds the fiber, act as a medium, protect fiber, prevent propagation of the cracks, which is very necessary thing. Essentials of the matrix phase. It should be ductile, bonding strength should be high, and it must be corrosion resistant. Uh, now I would like to discuss application of composites in a particular field. Here I am gonna discuss dental composites. We can see dental amalgam in the figure, and we can also see dental composites. See how aesthetic and compatible are dental composites looking as compared to dental amalgam. So let's have an introduction. What are dental composites? Dental composites or resin based composites are synthetic materials that combine polymeric matrix with the dispersion of glass, mineral, or resin filler particles in or short fibers by coupling agents. Just like dental amalgam, they are used to restore tooth structure lost through trauma, caries, or other disease. Yeah, tooth loss is a common thing. In many of the cases, people lose their teeth, so dental composites are a perfect solution for them in terms of strength as well as aesthetic. Here is a brief definition, uh, which we have already seen. Okay, next I'm having composite chemistry. Dental composite. Composite is composed of a resin matrix and filler materials. Coupling agents are used to improve adherence of the resins to filler surfaces. Activation system including heat, chemical, and photochemical initiate polymerization. Cross-linking monomers join long chain polymers together along the chain and improve strength. Coupling agents. Okay, what is the role of coupling agents? They are used to improve adherence of the resin to the filler surfaces. Coupling agents chemically coat filler surfaces and increase strength. So we can see how important coupling agents are for us. Next is heat catalyst. Polymerization of the resin requires initiation by a free radical. We are well familiarized with the concept of the free radical. Initiation starts propagation or continued joining of the molecules at double bond until termination is reached. Heat applied to the initiators break down chemical structure to produce free radicals. However, monomers may polymerize when heat is applied even without initiators. Heat catalyst, okay. Besides catalyst, we also have photochemical catalyst for the process. Presently, different composites use different photochemical systems. These systems are activated by different wavelengths of light. In addition, different curing lights produce various range of wavelengths that might not match composite activation wavelengths. This can result in no cure or particle cure. Composite materials must be matched to the curing lights. This is very important thing when we are making composites. Okay, let's have a look to the composite fillers. Fillers are placed in dental composites to reduce shrinkage upon curing. Okay, when curing is done, the light falls and wavelength is matched. Then dental components, there is a chance that they may shrink. So fillers are placed in dental components to reduce this chance of their shrinkage. Physical properties of components are improved by fillers. However, composite characteristics change based on filler materials, surface size, load, shape, surface modifiers, optical index, filler load, and size distribution. Okay, materials such as strontium glass, barium glass, quartz, borosilicate glass, ceramic, silica, polymerized resin, or the other are used as fillers in making composites. Now we have fillers classification. Fillers are classified by material, shape, and size. They can be irregular or spherical. Filler classification is also done on the basis of sizes, and we can see here uh, the one that begin from 10 to 100 micrometer are macro fillers, then mid fillers, Manipulars, microfillers, and nanofillers are shown. We can see the nanofillers are the smallest one, 0.0005 to 0.01 micrometer. Next is the concept of plasticizer. They are the solvents that contain catalyst for mixture into resin. They need to be non-active, non-reactive to the catalyst and resin. Physical characteristics, which are very important, are given below. Linear coefficient of thermal expansion, water absorption, wear resistance, surface texture, radiopacity, modulus of elasticity, and solubility. Okay, the one interesting factor here is the C factor. It is the ratio of the bonded surfaces to the unbonded or free surfaces in a tooth preparation. The higher the C factor, greater is the potential for bond disruption from polymerization effects. Oh, yes, how can we forget about the internal stresses? Where there are materials, there are internal stresses that exist. So, internal stresses can be reduced by self start, means polymerization, or incremental placement. There are advantages of the Dental composites, which are their aesthetics, conservative tooth preparation, insulative, bonded to tooth structure, and repairable. Disadvantages may result in a gap formation when restoration extends to the root surface. Technique sensitive, expensive, yeah, they are expensive, may exhibit more occlusal wear in areas of higher stresses, high linear coefficient of thermal expansion. Steps in composite restoration. Okay, when we are to restore composites, we do the following steps: local anesthesia, preparation of the operating site, shade selection, isolation of the operating site, tooth preparation, preliminary steps of enamel and dentin bonding, matrix replacement, inserting the composite, contouring the composite, and polishing the composite. Yeah, when we polish the composite, it's done. Principle of interior composite restoration are color and color analysis, which is very important in terms of aesthetics. Tooth color, tooth shape, tooth position must be considered, and aesthetic goals we know. Okay, smile design. Yes, this is a good concept. I mean, interesting concept. Smile design. Dentists must understand proper smile design so composite restoration can achieve a beautiful smile. This is true for extensive veneering and small restorations. Factors which may be considered: smile form, teeth form, and tooth color. Color and color analysis. Color is a study in and of itself. Dentists study the effect of enamel, rod surfaces, contour, surface texture, dental light absorption, etc. on light transmission. Reflection is difficult to understand and even more difficult to replicate. When we see tooth color, analysis of the color variation within teeth is improved by an understanding of how teeth produce color variation. Enamel is prismatic and translucent, which results in a blue gray color on the incisal edge. Interproximal areas and areas of increased thickness at the junction of the lobe formation. Next, we can see the tooth shape that requires recognition of journal form, and it may be disturbed due to aging, disease, trauma, and fear. Tooth position that matters a lot. Natural and beautiful smiles, um, it matters a lot. Understanding the goal um, and limitations of the treatment allows realistic expectations of a dentist and a patient. Again, there is aesthetic goals. The results of aesthetic dentistry are limited by limitation of ideas and limitations of treatments. Limitations of ideas are based on physical and obviously financial and psychological factors. Okay, now is the most important step, that is composite selection. Composite selection is done on the basis of the following factors. We have to consider restoration strength, wear, color, characteristics, ease of shaping, polishing, and color stability as well. Tooth preparations are done, defects are removed, forces are applied, mechanical retention and resistance, and bonded areas are seen. Then we need to understand the bonding techniques. Bonding techniques should be like they eliminate the sensitivity and prevention, and they must prevent the micro leakage. Enamel bonding is a well understood science. Dental bonding, however, is constantly changing as more research is being done. Requires constant periodic review. Next is the composite placement techniques. Composite placement techniques include the one which allow ease of placement, minimize effect of shrinkage, as I have already told, eliminate air entrapment and prevent material from pulling back from the tooth structure during instrumentation. In addition, dentists must understand placement of various composite layers with varying opacicities and color of the replicate normal tooth structure. Composite sculpture cannot be ignored. Composite sculpture of the cured composite is properly done if appropriate use of polishing, strips, burrs, cups, wheels, and points is understood. In addition, proper use of instrumentation maximizes aesthetic and allows minimal heat or vibrational trauma to composite, resulting in a long-lasting restoration. Then composite polishing is done, which have the following steps like preparations, metric systems, enamel and dent bonding, and composite curing. This is a whole process after which final polishing is done. Now, dental composites can be indirect posterior composites. They have larger restorations but have a significant amount of tooth remaining. It is used when a tooth defect is larger than indicated for direct composites and smaller than indicated for a crown. Common situation in fracture of a single gush in a molar or a thin gush on a bicuspid. Indirect composite restorations are processed in a laboratory under heat, pressure, and nitrogen to produce a more thorough composite cure. I have already explained the tooth preparation, and these are the steps discussed in more detail. Then is the composite wear. Abrasive wear is when a rough. Okay, it may include the abrasive wear. An abrasive wear is the one when rough material goes out the material on an opposing surface. A harder surface gouges a softer surface. Materials are not uniform, so hard material in a soft matrix such as filler in resin can be used. Chemical wears occur when environmental materials such as saliva, acid, or like affect a surface. Composite fractures are done. Now I'm going to discuss names of some composites, including silanes, which have been used to coat fillers for over 50 years in industrial plastic and later in dental fillers. Today, they are still state of the art. Moreover, we have resin pools, we have strikes or filler particles, resins, and many more. Recent advances, recent properties of a composite material can be tailored through microstructural design at different length scales, such as the micro and nanostructural level. Research also involves tailoring of the nanostructures of the microwires, ribbons, or the macro composites. Research have shown that shape fibers can be an effective means of improving the thorough thickness properties. A strength of guidelines of the fiber shape are preferred. Family of the fiber have been generated from the qualitative analysis for the role of reinforcing fibers in composites. Methods have been developed to produce such shaped fibers from glass in order to form reinforced laminates in sufficient quantity for material property testing using standard methods. Fiber shape has been shown to play a key role in contributing to the bonding force between fiber and matrix, with significant increase in fracture toughness possible. Results suggest that the shape of the fiber specimen have a greater thorough thickness strength than the circular fiber composites that are currently used. Self-healing should be considered when selecting a composite. Impact damage to composite structures can result in drastic reduction in mechanical properties. Bio-inspired approach is adopted to affect self-healing, which can be described as mechanical, thermal, or chemical induced damage that is automatically repaired by the material already contained within the structure. The release of repair agents from these embedded storage reservoirs mimics the bleeding mechanism in biological organisms. Once cured, the healing resin provides cracks, arrest, and recovery of the mechanical integrity. It is possible to introduce UV fluorescent dye into the resin, which will eliminate any damage healing effects that structure has undergone, thereby simplifying the inspection process for subsequent permanent repair. Fiber reinforced dental resins have greater significance than others. The material most commonly used in the construction of dentures is polymethyl methacrylate, and although few would dispute that satisfactory aesthetics can be achieved with this material in terms of mechanical properties, it is still far from ideal. Over the years, there have been various attempts to improve the mechanical properties of the resins, including the search for an alternative material such as nylon, the chemical modification of the resin through the incorporation of the butadiene styrenes as in the high impact resins, and the incorporation of the fibers such as carbon, glass, and polyethylene is considered. The use of self healing technology within the dental resin is a novel and exciting approach to solve the problems of the failing dental resins. Methods are currently being developed to translate the self healing resin technology into the dental and biomaterial science. Nanofibers and nanocomposites are of much importance as details are shown below. An electrospinning technique has been used to produce polymer, ceramics, and nanocomposite fibers for wound addressing, tissue engineering, and dental composite applications. The electrospun nanofibers have typical diameter of 100 to 500 nanometers. Natural biopolymers such as alginate, chitosan, gelatin, and collagen nanofibers have been investigated. Novel nanocomposites such as silver nanoparticles topped alginate nanofibers, alginate chitosan core shell nanofibers have also been investigated for antimicrobial and tissue engineering scaffolds. Zirconia, yes, we cannot ignore the importance of zirconia and silica nanofibers along epoxy composites, which are currently under the investigation for dental fillings in aesthetic orthodontics archwires. Carbon fiber composites are susceptible to sand and rain, erosion, as well as cutting by sharp objects. The use of nanomaterial in coating formulations can lead to wear resistant nanocomposite coatings. Work is developing novel fine particle filled polymer coating systems with a potential step change in erosion resistance and exploring their application to the composite propellers and blades. These tailored materials have a potential application in lightning strike protection and de-icing. Nanostructure of the magnetic microribbons or wires is being investigated and optimized to obtain the giant magnetoimpedance GMI effect for high sensitivity magnetic sensor application. The blow in the dental composites is the magnetic function of the composites. The main aim of this work is to examine methods including magnetic materials with a composite with maintaining structural performance. This have been achieved by filling hollow fibers with a suspension of the magnetic materials after manufacturing of the composite component. Research is continuing to tailor the magnetic properties of the composites to other applications. In another approach, magnetic microribbons and microwires are being tailored and embedded into the macro composite material to provide magnetic sensing functions. Oxatics. This is another dental material which is of composite nature. Oxatic composites or oxatic solids expand in all directions when pulled in only one, therefore exhibiting a negative Poisson's ratio. New concepts are being developed for composite materials, forms, and elastomers with oxatic characteristics for aerospace, maritime, and ergonomics applications. The smart the use of smart material technologies and negative persistence ratio solids have also led to the development of smart oxytex for active sound management, vibroacoustics, beside the structural health monitoring. Diamond fiber composites, they are diamond fiber reinforced composites. Coating, they have a thin coating of 100 micrometer millimeter diameter tungsten wires with a uniform coating of polycrystalline diamond using hot filament chemical vaporization method. They are rigid, stiff, and can be embedded into a matrix material such as metal or plastic to make a stiff, lightweight composite material with anisotropic properties. Novel multifunctional fiber composites. Okay, last but not the least are novel multifunctional fiber composites. New types of composites with a combination of strength, toughness, and functionality are being prepared by combining research in the synthesis of inorganic nanoparticles with that in the synthesis of organic polymers. This interdisciplinary approach has been used to produce flexible fibers of magnetic spider silk as shown in the photograph. We can search anywhere on the Google when we write spider silk. Silk fibers are coated by a tipping procedure using dilute suspensions of the inorganic nanoparticles that are prepared with specific surface properties. Similar methods are being investigated with soluble polymer gels and bacterial spurs cellular fibers to produce novel hybrid composites. That's all from my side. Thank you so much.